Welcome to today's tutorial. So in this tutorial we're going to be discussing how you can use implicit differentiation to find an equation of the tangent line to the ellipse or to any circle or to any curve in short. Alright, so the first thing that you need to understand is that first of all, if you have not yet subscribed to the channel, do it in advance. Click on the subscription button so that you don't miss out the videos that I'm going to be posting. Alright, so I was saying the first thing that you need to know is that what we always call dy dx, so dy dx is in most cases, not only in most cases, but is also known as the gradient function. So dy dx is also known as the gradient function, the gradient function. And then they're asking us to find the equation of the tangent line. So the other thing that you need to know about this question is that the line of the equation of the line is found by y, is found by using this, which is this equation, which is y minus y1 is equal to m then x minus x1. So given one point, which is 1, 2 in this case, 1, 2, and also the gradient, so we can use we can find the equation of any line. So if you have been given the gradient and at least one point, it's very easy for you to find the equation of the line. So this is the equation we're going to use to find the line, the tangent line. Then from these coordinates, that's where we're going to get our x1 and y1. So now let us find the gradient using what we've been given there as the equation. So we know to say dy dx is also known as the gradient function. So to find m, we're going to find dy dx using this function, which is in this case going to be found by using implicit differentiation. Alright, so let's quickly do that. So we have x squared plus y squared, then we have over 2 this side over 8, and then this is equal to 1. So for me to simplify this equation properly, what I'm going to do is that I'm going to multiply the whole equation by 8. So if I multiply everything in this equation by 8, I'm going to say 8 times x squared. I'm going to get 8x squared divided by 2. I'll get 4x squared. Then we say plus 8 and 8 there will cancel, meaning I'll just remain with y squared there is equal to 8 times 1. The answer is simply just going to be the answer here will simply just be 8. Or if you don't want to do this, you can just take this expression to the other side of the equal sign. Then from there you do the differentiation. And actually that's the simplest way we can do this. Let me not confuse you by doing this. Let me just take the other term to the other side of the equation. So I'm going to take this term to the other side of the equation. So if I take it there, I'm going to have so on the right, on the left, I'm going to remain with y squared over 8. Then this other side, I'm going to have 1, and then minus x squared over 2. So if I cross multiply here, I'm going to remain with y squared this side, which is just going to be equal to 8 times 1. The answer will be 8 minus 8 times x squared. This will be 8x squared over 2. That will be 4x squared. So this is the easiest way than the procedure that I wanted to use. Okay, so from here now, I think we can now differentiate using implicit differentiation. So when you differentiate this part using implicit differentiation, we are going to have 2 times the coefficient of y there will give us 2. Then we say 2 times y. Then 2 minus 1, we just have 1 there as the power. Then since we have differentiated y with respect to x, we always have to put dy dx here, since this is implicit differentiation. Then the derivative of a constant is always 0, and then the derivative of this expression here, we multiply 2 times negative 4 there, we get negative 8, and then we remain with x there. 2 minus 1, the power will remain 1 there. So our dy dx will therefore be equal to negative 8x, and then we're dividing everything by 2 so that we just leave dy dx this side alone, hence we're going to have over 2y, which can be simplified further to, so 2 into 8 there, we get 4, so this will be negative 4x over y. Okay, so that is our gradient function. So this is our gradient function. So now to find the gradient m, which we're going to use in this equation, we know that m is equal to dy dx. So this is our dy dx there. So the gradient m is equal to dy dx at the given point there, which is 1, 2. So the point there, x is equal to 1 and then y is equal to 2. So this will give us, so what this x will replace with 1, so we're going to have negative 4 times 1 and then everything divided by y, which is just 2. So the solution, which is the gradient, is just going to be, let me just write it here. So the value of m will now just be 2 into negative 4. The answer is negative 2. Yeah, so this is the gradient. Okay. Let us now replace the gradient there. Then we also put 1 and 2 in the equation. So we're going to have y minus y1 is simply just 2 there. So I'm going to put my 2 there. Then we say this is equal to, my gradient is simply just negative 2. I'm writing there my value of m, and then I'll also have x minus x1 is simply just 1. Okay, so we can simplify this. We say y minus 2 is equal to negative 2x. Negative 2 times negative 1, we get positive 2. So when you take negative 2 to the other side of the equal sign, y will simply just be equal to negative 2x plus 2 plus 2. So the value of y becomes negative 2x plus 4. So this is what you are going to have as the equation. So after finding the equation of the line, this is the equation they wanted us to find. There is also this question here which has been asked to say we have to show that the equation of the tangent to the line, the tangent line to the ellipse, this ellipse here, at this point x0, y0 is simply just given by this expression. Alright, let's do that. So this is also simple. Okay, so let's quickly do that. So this one is also straightforward. So we have okay, so we have the this question, part B. So we also do the same procedure that we took when finding the tangent line to the first one. It's the same procedure that we're going to take here. So we first take this expression to the other side of the equal sign, or they want us to show that it's equal to that. So I think what we can do to simplify our work, let's just take the derivatives of without taking this to the other side, just the way it is. So let's take the derivatives like that. Or I think, anyway, let's just take them to the other side so that we make our work easy. So we are going to say y squared over b squared is equal to 1. I'll take this to the other side, which will be minus x squared over a squared. So I'm trying to find the gradient. So this will go, I'm going to cross multiply here, or even just, yes, I'm going to cross multiply to make my work easy. So this will just remain as y squared is equal to 1 minus x squared over a squared. Then we have b squared this side. Okay, so my y squared will now be equal to b squared times 1. This will be b squared, and then we have minus b squared over a squared, then we have x squared. Then we find the derivative of this to find dy dx. So the derivative is simply just going to be dy dx of this will now just be so this will give us 2y dy dx is equal to, and then this part here is a constant, so it will be a 0, so we'll just have this part. So if we differentiate this part, we're just going to get negative 2b squared over a squared, and then we have x, rather not x squared but just x. Okay, so this is what we're going to have. So we can now divide everything by 2y. Can now divide everything by 2y so that we just remain with dy dx. So dy dx will therefore be equal to, when you divide 2 and 2 there, this side we're just going to remain with b squared x over, there's this y. If we divide y on both sides, we're going to have y down, then we'll still have our a squared. So this can also be written as dy dx is equal to, oh, there's a negative in front, is equal to negative negative b squared over a squared. Then okay, let me just put them the way they are. Then we have x over y. Okay, so this is our gradient function. So now to find the gradient, we replace back x naught and y naught. We replace them in this equation. So we are going to have our dy dx as negative b squared over a squared. Then while this x we put x naught, then while this y we also put y naught. Okay, so now this is the gradient. We know that dy dx is also known as the gradient function. So we replace the gradient in the given expression, in the expression for the line, in the expression for the straight line, or for the equation of the line in short. So we have y minus y1 is equal to m times x minus x1. So once we do that, we can now say y minus, while there's y1, I'm going to put y naught, and then we say this is equal to m. My m is simply just what I'm seeing here, which is just negative b squared over a squared. Then we have x naught over y naught. We're multiplying everything by x minus, then we have x1 there, so my x1 is just equivalent to x naught there, so we put x naught there. So we make now this equation to look exactly like this one, because we've been told to say we have to show that the equation of a tangent to this line at this point is can be written like this. So we have to write it like this. So how am I going to simplify that? Simple. So the first step that I'm going to take is to distribute, is to multiply this expression through the brackets there. So I'm going to have y is equal to, or not really y is equal to, but y, or maybe let me simplify my work by saying y minus y naught. Okay, I just cross multiply here. Let me see how that will simplify my work. Y minus y naught. So I'm multiplying this by a squared y naught, and then this side I'm going to remain with negative b squared x naught, open brackets, x minus x naught. Okay, so from there I think we don't have to multiply this. Let me divide everything by b squared. I think that's by negative b squared. I think that's the easiest way we're going to do this. So always when you're solving mathematics, you need to know where you're going to help you to arrive to the right answer. But if you don't know where you're going, you're just solving, it's really difficult to even know that you have arrived at the answer. Sometimes you can even solve and pass the answer. So here we had something like this was y naught. So I'm saying for me to make my work easy, I'm going to multiply through this a squared over y naught in these brackets, and then I'll also divide the whole expression by negative b squared x naught. So this will be y minus y naught over negative b squared x naught. Then we say this is equal to x minus x naught over a squared over a squared y naught. Okay, so I've erased this other part so that we create more space. So let me do this, then let's do the cross multiplication here. Let's see where we are going to go. So if we multiply a squared and y naught with what we have there, we're going to have a squared y naught times y, then minus a squared y naught squared, because y naught and y naught multiply. Then on this other side we're going to have negative b squared and x naught multiplied by x. We're going to have negative b squared x times x naught, and then plus we'll have b squared, because negative times negative will give us a plus. We'll have b squared, then x naught squared. Yeah, so I have b squared, we have b squared, and then x naught squared. So this is what we have. Then let us organize this in such a way that we have something which looks like this one. So let us take the ones with x naught and x and y naught and x, let's put them on one side. So we are going to have x naught, where is it? So x naught and x and y naught and x and y naught and y, we put them together, so we have x naught and x. So I'm going to get this part. Yeah, so I'm going to get this part. I have a squared y and y naught. Then I'll also have I'll bring this part to the other side of the equal sign so that it becomes b squared x naught. Then I'll take the rest to the other side of the equal sign as well. So when I take, so this side I have b squared x naught squared, then this also will go this other side, which will be which is just going to give me plus a squared y naught squared. Okay, so now what I'm going to do is I'm going to divide everything by a squared, and then later on I'll also come and divide everything by b squared. So if I divide everything by a squared, this part over a squared, okay, let me say a b squared. So let me just do it at once. So I'm going to divide by b squared a squared, even this one b squared a squared, then this one b squared a squared, then this one b squared a squared. So you can see that here a squared and a squared will cancel. Here b squared and b squared will cancel. So let me start with this one because it's the one that they started with there. So I'm going to start by writing this one. So I'm going to have x naught x over, down here I've just remained with a squared, then we say plus, even let me also write this one now, which is y naught y over b squared. This is equal to, and then this other side, this and that to cancel. So I'm going to have x naught squared over a squared, then plus, then this other side, and then this other part, this other part will give me y naught squared over the a squared, and the a squared will go, which will be b squared down. But when you look at this expression, don't you think it looks similar to this? Yes, they look similar. And if they are similar, don't you can't you assume that this is also equal to 1? If the answer is yes, meaning while there is this expression in this expression, I'm going to replace that with 1. So this is just going to be x naught x over a squared, then plus y naught y over b squared is equal to 1. And this is how we show that the tangent, or the equation of the tangent line to the ellipse, this ellipse at the point x naught comma y naught, is given as that. So this is the equation. So thank you very much for watching this tutorial. So the same way I've solved this question 3, that's the same way you can solve the next question, which is question 4. You can solve it in a similar way and you get the same answer, except that here there will be a minus. Alright, thank you very much. I mean, at this point there will be a minus. Okay, so thank you very much for watching today's tutorial. Let's meet in the next tutorial video. My name is Harmtedy. Shalom, shalom. If you have not yet subscribed to the channel, make sure that you do that, and also don't forget to click the notification button so that you don't miss out the videos that I'll be posting. See you in the next tutorial video. My name is Harmtedy.